Okay, so here we go with the big trick and areas of sectors and arc lengths worksheet. First question is nice and easy. Calculate the area of triangle PQR. So to calculate the area of the triangle PQR, I want to use the area formula from this section of the course. If I've given an angle in a triangle and I'm asked to work out an area, that should point you straight away towards a half AB sine C. Remember, we're looking for our A for area. Here's my A for area over here. And those are the measurements I want to use in this formula. So I'm going to plug in a half times 2.8 times 8.3 times sine 79. And I'm going to do that now. A half times 2.8 times 8.3 times sine 79. And that's getting me 11.4. And that's going to be in centimeters squared. Let's move on to the next question. So in this triangle, I'm asked first of all to calculate xy. So this is two triangles stuck together, and actually there's a third triangle which is all the way around the outside. Sometimes that might be quite important for us. But right now I'm just interested in calculating this. Now we can see in this triangle that I'm interested in a formula which involves 3 sides and 1 angle. There's only one formula we have that involves 3 sides and 1 angle, and it's the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Remember, in the sine rule and cosine rule, we're looking for opposites. So I've got a side and an angle opposite that need to go on the opposite ends of the formula, and the rest gets filled in however you want. So x squared equals 12.5 squared plus 9.9 squared minus 2 times 12 times 9.9 times cos 23. I can stick everything on that left-hand side into my calculator, and that's going to get me, well, give me a moment, 9.9 squared minus 2 times 12.5, I forgot my 0.5 over here, times 9.9 times cos 23. So altogether there, I'm getting 26.435. And I'd want to square root that to get my final answer. So I'm getting 5.14. Certainly that measurement seems to correspond with the other ones I'm seeing in the triangle, so I'm pretty happy with it. A lot of the time people forget to do the square root, but if you look at the 26, that really doesn't look like it could be the length of the thing, even though we're told the diagram's not drawn to scale. So that bit's done. I'm now asked to calculate t to z, so I'm going to call this thing over here y. So looking in this second triangle over here at the measurements that I've got to work with, I'm looking for a formula that involves 2 sides and 2 angles. And our only candidate is the sine rule. Y over 72, sine 72 degrees, is going to equal 9.9 over sine 37 degrees. Once again, just like with the cosine rule, I'm following this idea about opposites to remind me how I'm supposed to substitute into these formulas. So, y equals sine 72 times that fraction, 9.9 over sine 37. And I'm going to type that all into my calculator and get myself an answer. So I've got sine 72 times by 9.9 divided by sine 37, and that's getting me 15.6. 15.6 centimeters. And again, let's just look at that answer and see if it makes sense. We've got 9.9 centimeters opposite the 37-degree angle. This is a bigger angle, so I'm expecting a bigger length, so that checks out. Let's look at the next question. This one's quite an interesting problem-solving question, so let's break it down carefully. This diagram shows a shape made up from 3 identical sectors of a circle, each with a sector angle of 65 degrees, and the total perimeter of the shape is 20.5 centimeters. And I want to calculate the radius of the circle. Well, that radius appears in the perimeter over here and over here. If I was working out the length of the arc, I would need to use the arc length formula. The arc length is equal to whatever the angle is, theta over 360, times the circumference of a circle formula, 2 pi r. So this thing over here, in this case, is 65 over 360 times 2 pi r. Now, that gives me 65 times 2 pi is 130 pi r over 360. And in fact, let's just divide by 10 on top and bottom because that's a fairly straightforward thing to do. 13 pi over 36, here, and here, and here. Nowhere in this question does it ask for an exact value, so you could be working out all of this as some great big decimal times r, and you could use that. I'm not doing that because I'm aware there are questions that can pop up where they actually do insist that you work in exact values, so we're doing it for practice. Also note that I've taken some efforts to simplify this as much as I can, because I'm going to have to work with all this quite a lot. And I want to work with the simplest, smallest thing I can. So now all of these measurements added together are going to make the perimeter of the circle. So 2r plus 3 times this fraction over here is going to make up my perimeter. 3 times 13 pi over 36 is actually going to turn out to be 13 pi r over 12. Timesing the fraction by 3 is the same thing as making the denominator 3 times smaller. This thing equals 20.5. Now, at this stage, we could work out what 13 pi over 12 was, we could collect our r's together, we could divide, and we could solve it that way. What I'm going to do is just something a little bit more sophisticated, just to demonstrate another approach. You don't have to do it this way. I'm going to factorize the r out, thinking about how I'd rearrange a formula, and that means that r is going to equal 20.5 over 2 plus 13 pi over 12. And now I'm going to work that out all at once. The advantage to this is that I'm minimizing my rounding errors, but once again, you could have given in and written down decimals very early on. I'm not suggesting that you should do it or you need to do it the way that I'm doing it here. I'm just trying to show an alternative approach. So this is 3.79 centimeters for my radius, and that's the end of the question. And we'll do more in the next video.